All right, let's look at the homework 10.4, problem number 2. All right, so we want to find the radius of convergence of this power series here. All right, so let's do that. So we're going to basically do a ratio test. So here, this is going to be our AN, right? Then we have AN plus 1 would be -1 to the n plus 1, and then you have n plus 1 factorial, and then quantity x minus 3 to the n plus 1 all over 4 to the n plus 1, right? So let's do the ratio test. So you have a limit as n approaches infinity, right? Absolute value, right? Remember you put an plus 1. So you have -1 to the n plus 1 quantity n plus 1 factorial, and then quantity x minus 3 to the n plus 1 divided by 4 to the n plus 1, right? Then over an, so we just put the reciprocal of that. So you have a 4 to the n on top. Then we put -1 to the n, n factorial, and then quantity x minus 3 to the n, right? So let's clean it up. All right, first thing we can get rid of is that -1 to the n plus 1, or -1 to the n, because it only changes sign. But because of the absolute value sign, these guys will not do anything. So we just cancel them out. All right, so you have n to the fourth on top, 4 to the nth power on top, and we have n plus 1 of those. So I'm going to scratch n plus 1. So you have 4 on the bottom, right? Then here, n factorial, and then you have n plus 1 factorial. If you cancel them out, you can cancel n factorial, and then you can just cancel this factorial, because you have n plus 1 left over. And then we have x minus 3 to the n, and you have n plus 1 of those, so I'm going to scratch that. You have another one left over. All right, then we just have to clean it up a little bit here. All right, so we have, all right, so this is going to be is equal to, all right, you have a 4 on the bottom, so I'm going to put 4 on the bottom outside, right? So we took care of this guy right here, right? And also here, this guy has x minus 3 has nothing to do with n. I can pull it out, but with the absolute value sign, so you have a x minus 3 pulled out. All right, then you have a limit as n approaches infinity. All right, what's left would be actually just this guy, right? N plus 1. So limit of n plus 1 as n approaches infinity. You can see that definitely this guy is going to go to infinity, right? So this is going to be infinity, right? So therefore, which is always greater than 1, so this is actually always divergent, right? So the radius of convergence is going to be 0, right? So here, radius of convergence would be 0. And the only value that this can converge would be x equals 3. If x equals 3, the whole term becomes 0. So the sum is going to be 0. All right, so let's type it in. All right, so radius of convergence is 0. All right, let's check the answer. All right, it came back and looks like we got the radius of convergence correctly. All right, that's it. I hope that this was clear.